Thank you. And we're live streaming now, so when you ask questions, please use a microphone because there are people all over the metro region and we hope globally that are watching this live stream. No pressure for Howard, but we will be live streaming. So Howard was talking about how this whole arc from product design through to manufacturability is changing because of Industry 4.0. And Industry 4.0, for those of you who don't know, it's the fourth industrial revolution. It really is how the digital world is overlaying onto the physical world. And the implications for that are huge when it comes to how things will be manufactured, where they'll be manufactured, and the speed with which they'll be manufactured. And it all starts at the front end with design, because now you have to design and simulate and visualize and redesign all in real time through iterative cycles with the intent to be able to manufacture it at the end of the process. In the old days, the engineers that designed had a binder of drawings and the manufacturing engineers had a binder of drawings, and they weren't even the same drawings. So what was being designed and manufactured were completely separate things. And the engineers in manufacturing wouldn't let the design guys touch their binders. And the guys in design wouldn't let the manufacturing engineers touch their binders, right? So you had this massive communication disconnect, and it slowed the process down. Today, what you're going to learn from PTC is how to speed that process up. So I thank you for being here. Please use the microphone. For those of us joining live streaming, thank you for being with us, and spread the word that this is a place you can come to get knowledge on Industry 4.0. So with that, I'm going to turn it over to Howard Heppelman.
Thank you, Tom.
Thank you. Oh, you're all set. Thank you, guys. Enjoy the day.
Great. Can everybody can hear me okay? Sounds good. Okay, so far so good. Good. All right. Thanks. It's an honor for me to be here today. As Tom said, I also had an opportunity to participate in the Integrate conference this past year. And I'm actually going to share a little bit of that content here with the audience, both in the room and online today as well. But, you know, this term Industry 4.0 really is speaking to the fact that there are a number of technologies that are converging today, coming together and really providing a step change opportunity for how industrial manufacturing companies think about creating value and accelerating digital transformation. And so I want to give you some of the perspectives that we at PTC have garnered in working with thousands of customers on this topic, and then at the end, hopefully, we can take some questions. I also am going to try to do some demonstrations. If all the audio-visual stuff cooperates with me, that'll probably be interesting. If not, sometimes we have challenges, but it was working beforehand here. Just a quick show of hands here in the room. How many people know PTC? I assume most of the audience, not everyone. Okay, good. So just a quick introduction to the company. We are about a 25-year-old company, about 6,500-ish employees around the world. We're considered to be a sort of medium software company. You know, just by size, we do a little over $1 billion a year in revenue. But if you look at the fact that we are focused solely and exclusively on manufacturing, it kind of puts us into the big software category within that space. What we've been doing for 25 years, we started out sort of transforming the CAD design space with a product called ProEngineer that today we call Creo, but it was really the first 3D modeling tool to reach scale in industry. And then we went on to launch the first web-based PLM system in a product called Windchill. And then we had customers asking, well, how do we take that rich design data and, as Tom was saying, share it stream process in the world, both with manufacturing and service. So that led us into buying a host of products under a brand name that we maintain called Servigistics for service. So kind of this history has been starting in design, moving into how you leverage design information in manufacturing, and then how you leverage that product content downstream in service. We saw about 5 years, probably 7 years ago that this idea of the Internet of Things was going to change how companies perceive those functions, design, manufacture, and service. If you could connect a product, you know, the whole concept of product lifecycle management has traditionally stopped when products leave the factory, but now products have an opportunity to have a voice, a continual voice in the process. And so you can really have a closed loop concept to the idea of lifecycle management. And we saw that. We said, you know, our customers are going to be designing a lot of sensors into their products. They're going to be leveraging that product data back to better inform how they engineer the next generation of products. They're going to be using that connectivity in their factories to knit their factories together so that they can have real-time operational control. And they're going to use that information downstream in functions like service and even sales and marketing to understand what's going on with their products in the hands of their customers. And so we went out and started looking at how can we help our customers sort of through that transformation. We acquired a host of technologies, a portfolio of IoT technologies, a platform called ThingWorx, which I'll talk about today, another one called Exida. We acquired some very interesting technology in the factory through a company called Kepware, which basically provides drivers and connectivity to all the PLCs and devices that you'd find in a factory. We acquired a machine learning and analytics company that we've integrated in today into what we call ThingWorx Analytics. Actually, I should move to, the next slide here. And most recently, we acquired a very interesting technology called Vuforia, which is in the augmented reality space. So these are just my 2 slides on PTC. So if you didn't know us, or maybe if you did know us, but you knew us in one of these previous contexts, today the company is quite different. We still have at the core of our foundation are what we call traditional PLM products, CAD and PLM and the service software capabilities. As well as Integrity is the application lifecycle management space for embedded software. But the IoT space is what we call the industrial innovation platform. And that's comprised of technologies like ThingWorx, Kepware, and Vuforia. And then on top of that, what we do is we build accelerators so that as companies are embarking on this Industry 4.0 strategy, they can get going very quickly. You know, this doesn't have to be something for just the biggest companies. It can be attainable to small and medium-sized companies as well to get started on that journey. And then finally, in this world of sort of digital transformation, it's all about an ecosystem. We don't pretend at PTC that we're going to solve every problem you have. What we try to do is bring together an ecosystem of partners, integrators, resellers that can help through that transformation. So just a couple that I'll call out that we announced a couple weeks ago at our main annual event called LiveWorx. We recently signed a partnership agreement with Rockwell Automation. As we like to say at PTC, this isn't a Barney partnership, you know, the I love you, you love me kind of partnership. In this case, Rockwell invested $1 billion in PTC. They bought our stock at, I think, $86, spent $1 billion. Blake Moret is now a board member at PTC. And that has driven us to a very tight collaboration for how we're going to bring their technologies in the factory together alongside of our ThingWorx industrial innovation technologies to help create a best-in-class portfolio for people who are looking at the opportunity to drive digital transformation across the factory. So very exciting, about a month old in terms of the announcement there. Partnership with Rockwell Automation. The second one I want to mention, and then I'll move on, is Microsoft. So PTC has a strategy where we're really cloud agnostic in terms of deploying our technologies. So if you have Amazon or Microsoft or Google or SAP, you can put our industrial innovation platform on top of those. But with Microsoft, we wanted to have a strategic partner that we could co-develop solutions with that would help either our customers who care about connecting their products to a cloud, or our customers who might want to connect many factories across their enterprise to a cloud, to be able to do that in a very secure way, but be able to innovate across that environment very rapidly. So a couple of partnerships, but many are not shown on this slide as well that are very important. Okay, so that's a little bit about PTC. What I want to talk about now is sort of this idea that Tom mentioned of digital physical convergence. And we saw about 7 years back, as I said earlier, that this trend was unpacking or unfolding in industry where, if you look back 20 years, products were mostly mechanical. One of our very first customer ever, John Deere, when we sold to them, they made tractors, and their tractors had almost no software in them, and it was all mechanical and lots of mechanical engineers. In a relatively short period of time, 10 to 15 years, that switched to where there actually is many software engineers, or perhaps more, working on the products as there were mechanical engineers. And so products started to get smart, and then those products started to get connected to the internet so that you could get some feedback and data from those products. And then people started to ask, well, if we've connected the products to the internet, how can they start to work more together? So using the John Deere example, if you're in the business of selling equipment to companies or to customers who hope to improve yield of their farming operations, they don't just care about the plow or the seeder or the fertilizing equipment or the weed management capabilities or the irrigation capabilities. What they care about is how do all those things work together in the most optimal way so that I can minimize the resources I'm applying and get the best yield out of my land. So that was a good example of this connected system, but now you can take that a step farther. Using the farm analogy today, you would care about, well, how do I integrate third-party information, perhaps from the irrigation perspective? I don't want to irrigate the entire field. I only want to irrigate the places where I've laid down the seed, or fertilization, or how do I use geotechnology mapping capabilities to look at the actual moisture content in soils so that I know how to best fertilize and to get the most out of it. So we get into this system of systems environment. And for us, that is the factory. That's what people in a factory environment live every day and have been living. You've grown up in a world where you've acquired a lot of technologies. In a best case scenario, you might be semi-homogeneous in a factory, but as soon as you go to the factory that was started up 20 years ago, that's no longer the case. And so the question is, how do you get your machines, your business systems, your supply chain systems, all to work in harmony to drive continuous improvement in efficiency and quality? So that can kind of be viewed as the, what today we're calling Industry 4.0. The opportunity is really around digitally connecting all of these systems together so that you can drive increased productivity and efficiency. We're fortunate at PTC that we had the opportunity to work with Professor Michael Porter. If many of you probably know him, he's a Harvard business professor that is sort of world-renowned in the area of business strategy. He was on our board for a while. He is not any longer, I think for 5 years now. But he's published a lot of information over time about how information technology is shaping the value chain. And so his sort of view has always been that, if you go back in time, we moved really into technology in the 60s with sort of the personal computers or company computers. And that helped digitize some information inside a company. And then the internet came along and created another boost of productivity by allowing us to take that information outside of just our company and start to connect together the value chain. The first of a series of articles that we've published with Professor Porter in the Harvard Business Review, and we can give you copies to that, or you can find the links on the PTC webpage, was titled How smart connected products transform competition. And it took this idea that it's no longer about how we as humans share information back and forth across the internet, but now that products or machines have a voice in that process, how do we knit them together so that they become a active participant in the value chain? So you've got your customers and your suppliers and your own resources, but you also have your products that become actually one of the most reliable and consistent sources of information. So that was this idea that IT is embedding itself in products and unlocking a completely new opportunity for efficiency improvement. And then most recently, there's a companion technology to that, and this is, if you think about technology in general, right? Technology continues to grow exponentially, and need to in that process, what are the tools that allow us to keep pace with digital technology? It moves very quickly. You can't read it all, you can't study it all. So how do you keep pace with the technology? And really, augmented reality is the way they do that, and analytics as well. But there are two critical technologies that allow humans to remain key participants in the digital transformation. One is analytics, and the other is augmented reality. And I'll touch on that here in a second. So the third article that we wrote with Professor Porter, the most recent, was titled why every organization needs an augmented reality strategy. You can find this again it was in the, I think, November, December issue of HBR last year, but we also have copies of it. And I want to, if this is my first test to see if the system here is going to cooperate. So when we talk about publish an article with Professor Porter, our CEO, and Professor Porter on the importance of augmented reality, we thought that it would be interesting to, good, so far so good, to do that in a way that allowed you to use augmented reality to understand it. Sorry. So what we've done here, this is just fun. I'm gonna show you some more meaningful examples in a second, but we've taken the article, and out of this first page in the article emerges a factory, and we're talking about factory. In this case, the factory is just producing, a piece of paper comes out, some information is being added, and some more detailed information here, and at the end it's just fires off a paper airplane. Okay, kind of fun stuff, but we'll get to a little bit more meaningful context in a second. But just imagine in that short little demo I gave you, how cognitively, how much information you can take in. I mean, the idea of augmented reality as a disruptive technology is akin to the thing that we always hear about, which, you know, a picture's worth 1,000 words, right? If you take a quick experiment here, and I'm going to ask the folks in the room to do this, I'm going to ask you to close your eyes, and then I want you to open them for 1 second and close them again. So go ahead and do that. And in that 1 second when you open them, just, you know, absorb what the point here is. That think about, in 1 second, how much information you were able to consume about the people in this room, the shape of the room, the size of the room, you know, how it's laid out, et cetera. And then think about how long would it take you if somebody said, hey, I'm going to give you a stack of paper, and I want you to read about this room, and imagine that. Or I'm going to give you a video, right? And that would be a much faster step toward it. But the idea is the human brain, this is the concept of a picture's worth 1,000 words, the cognitive pipe going into our brain can carry so much more information when we're doing that visually than any other mechanism. Yet most people today, most workers in today's industrial environment, are constrained to the lowest forms, which are text and voice. And really that's why it is such a transformative technology. And I'll give you some more examples of that as we go through here. Okay, so what I want to talk about is this idea that there are many technologies today that have emerged individually can give companies an opportunity to create value or and present the opportunity for them to be disrupted. But when you take technologies in aggregate, there is no question in my mind that 5 years from now when we look back and we say, well, what was the impact? You know, it will be something like the internet. At the time, in 1999 and the early 2000s, when everybody was lathered up about the internet, no one knew exactly, you know, what the end state would be, that we would end up with Amazon and Google and Uber and all technologies that would completely emerge and disrupt well-established 100-year-old businesses. And today, if you look at, this is from both Gartner and PwC, but you can find, you know, 50 other documents that talk about these disruptive technologies. Things like artificial intelligence and virtual and augmented reality and digital twins and intelligent things and intelligent apps and digital technology platforms. You know, each of these technologies has the potential to create enormous value within your operations, but when you put them together and you look at how do I leverage them in aggregate, it will absolutely transform business. And that's what I want to talk a little bit about. Okay. In industrial manufacturing, I think, you know, in the day-to-day conversations that I have with customers, there's 4 big topics. It doesn't mean they're the only topics, but there are 4 big ones. Certainly things like blockchain is a disruptive technology that's going to have an impact. Not so much today in the manufacturing space, although I wouldn't say not at all, but it's not the leading technology there today. But the 4 big ones are industrial IoT and analytics, and I put industrial IoT and analytics together. It's both connecting to the sources of information, again, IT and OT, so information systems, business systems, and OT meaning machines, devices, etc., PLCs, and then using the data coming off of those devices with analytics to filter through it to help make systematically better decisions or to help humans make better decisions. In this space, today, you know, PTC has over 1,000 customers that we're working with in the IoT space, and we see in the factory area that, you know, they can get anywhere from a 5 to, quite frankly, 30% improvement in efficiency by applying these technologies. In the case of many of our customers, they're highly automated businesses, so think of hybrid manufacturing or process manufacturing. They're already very automated manufacturing environments, but an extra 5% of efficiency improvement is enormously valuable to companies operating in that space because the margins are so narrow. Whereas in the discrete space, there's really a much broader opportunity for automation because that space has lagged these more, the more automated spaces of continuous manufacturing. So anyway, the first technology, I'm going to give some examples of each of these, is this idea of IoT and analytics. The second one I already touched on, but I'm going to go into a little bit more detail, is around augmented reality. And quite frankly, the simple way to think about this is augmented reality gives humans superhuman capabilities. If your current method of working with information is through electronic documents or paper documents and put side by side with somebody who is able to use augmented reality in the visual in-context delivery of information, I don't think there's any question on who will be more efficient in that environment. So augmented reality, and again, we're seeing that in workforce-intensive environments has the potential to drive a 30 to 50% improvement in workforce efficiency. And then the third in the industrial manufacturing space is really this idea of additive manufacturing. You know, we've been playing with additive manufacturing for many years on the design side for rapid prototyping and things like that. In fact, I think it was 20, the first rapid prototype using, I think, STL was printed from a CAD model out of Creo. But today we're talking about it in a very different way. We're talking about how do we use additive to eliminate the barriers for manufacturing that have constrained the world up until this point. And what do I mean by that? We've always started with the idea that there's a solid and we're going to take things away from the solid to end up with a product. And in the additive world, you can start really with a boundless envelope of innovation and say, if I could build something up, what might it look like in its most optimal form? And so you get a lot of concepts like what they call biomimicry, which is looking at how does nature design things. You know, the veins that flow through our body look nothing like the plumbing that's in a building or piping, right? Because we're constrained to a certain envelope of capabilities with traditional manufacturing. But you can print very interesting things using additive. So additive is really the third area, and you know, I don't know that you can put a number to it, but what is certain here is that it will allow us to imagine products in a completely new way, which will allow us to shed much of the baggage that we have today around how those products must be manufactured. There are companies today that are taking 1,000 component assembly and reducing it to 20 or 30 parts. Imagine the impact of that on the value chain. If you can shed, you know, whatever that would be, 870 parts out of an assembly, what it means to the role of the suppliers and the number of suppliers you need and the capital equipment that's needed up and down the value chain to produce that, the time that it might take to get it there. So this is still early, but it is going to have a very transformative outcome. Okay, the fourth technology, and for this one I'll lean back to that Gartner slide that I had, is around what we call digital technology platforms. The idea of a digital technology platform is there a way that I can use these technologies in aggregate, in a system, to advance my capability set much more quickly. So one approach is you could go out and say, well, we're gonna do some stuff around connectivity and IoT, and we want to find out what the best way to connect our devices is, and then we're going to build some applications on that, some web applications. But oh my gosh, if you want AR in that, then you got to figure out how you integrate AR, and then you have to go, you know, think about what analytics tools am I going to use, and if you're don't have a digital technology platform that allows those tools to snap in, then you have to go integrate all of that. So the concept, as Gartner would say, with a digital technology platform, is you bring many of these disruptive technologies together into a platform that then allows you to leverage them through your digital transformation at a much greater speed and velocity. Okay, so I'm going to give some examples of those. Before I do that, I think we probably all are familiar with this picture. I mean, this is kind of the environment that exists today, at least in a factory setting. We've got this 5-layer cake of the ISA 95 model. The challenge with this model is that data is generally not well integrated. You know, the millisecond kind of responses that you expect at the bottom of the stack are quite different than the weekly responses that you might be looking for at the top of the stack. And the OT data, the machine data that's real-time streaming data, doesn't really tie together nicely with the business systems data. And the business systems themselves tend to be more silos of automation than completely integrated systems. Or if they are, you've probably spent many tens of millions of dollars to get to that environment. So this is the environment that we're in today. The opportunity with these digital technologies and a digital technology platform is you sort of lay alongside these horizontal layers a vertical stack of technologies that bring modern technologies, connectivity, big data, augmented reality, analytics together, and enable an abstraction from all the complexity that exists at the system level to innovate across that layer at a top level. The ultimate state here is that you want to be connected both to machines, humans, and systems in real time. You want to be able to serve that information up to the people that need it in the context they need it, just when they need it, so sort of role-based applications. Enable predictive and ultimately prescriptive capabilities, so let me monitor those data flows and look for patterns or anomalies, can light on something that is going to happen in the future or a way to optimize something in the future. Bringing in modern technologies like mobile and mobile technologies, phones and devices, along with augmented reality, so that if the best way for me to deliver an experience to a user, giving them an augmented in-context experience, let me do that as opposed to serving up a 2D web screen. And the general concept of all of this is that it allows you to wrap your existing environments, not necessarily replace existing environments, but wrap those environments with a layer of technology. Again, the Gartner term would be digital technology platform, that then allows you to innovate much more rapidly across those underlying data sources. So one example of that I mentioned already, this idea that in some industries, there's a high degree of automation. The food and beverage industry is such an industry. This particular company makes chips and cola, but it's very important to them if they can get a couple of % increase out of their operations, the impact that that has on driving margin improvement. And in this case, they had a lot of silos of automation, lots of automation technology, ERP, MES, all of that technology. But we're really missing the way to stitch that all together in an effective manner so that they could have real-time insights across their operations, which would allow people to instantly react to opportunities or problems or threats that were developing in their production environment. So they're seeing a 5 to 8% improvement in the factories where they're deploying that technology. Automotive supplier that has to be in Japan. Treating component production line, a furnace farm production line, they'd have to power it down and then have the team treat the equipment to find out the safety issues or certainly for safety issues. By connecting those devices and then integrating the relevant data sets, we were able to help them deploy a predictive model that would tell them 24 hours in advance with 91.7% accuracy when a furnace was going to throw an alarm. And then that gives them an enormous opportunity to reduce unplanned downtime by dealing with that issue either at shift handover or whatever the most convenient time is between now and that future state, which would result in unplanned downtime a day out. So this is kind of the combination of connectivity and analytics. Okay, I want to talk again about AR. So now I want to not just use the fun example that I showed earlier, but kind of use a real customer product and example. And to do that, I'm going to go back to this article. Again, I would encourage anyone, everyone to grab this off of the HBR website or the PTC website. The product that I want to show here is, well, you'll see it in a second. I guess I don't really need to describe it. So this is many of you may have similar products in your factories. This is a Bosch Rexroth hydraulic power system. And they were kind enough to work with us in this article on sort of these use cases. And what you see, though, in the article is it says there's really 3 key things that augmented reality allows you to do. The first is visualize data. This is the 1-second test I had you do earlier. The second is to be able to instruct and guide people through operations using that visual content. And then the third, which might be a little further out in the future, is the idea that you can interact with your physical environment using augmented reality. So if I look at the first one, I got to require the image there. I'm going to press the button to help understand what does it mean to visualize the data. So I'm pressing the button on the magazine on my phone. And using all the rich content that you've created upstream in your companies and engineering, whether it be in PTC tools or other tools, you can build these animation experiences and bring in, the data we're bringing in here. Some of it's coming from the device operating, but some of it's also coming from, the CAD document or drawing, or it might be coming from a PLM system or whatever. We're merging all of that data together into an augmented experience. So many, many use cases for this, from sales and marketing to service, et cetera. The second interesting thing about augmented reality is this idea of you can instruct and guide workers on executing procedures. So in this case, it says, warning, there's a filtered contamination. That was noticed because we're connected to this device. This is obviously simulated data, but if you have a filter contamination, this is the process that you go through for replacing that filter. Okay, we took that one out. Put a new one in. Put the cap back on and snap it back in place. Simple process. So that's interesting. And then the third example here is the idea that you can use augmented reality to actually interact with the environment. So we're going to fire up a digital twin of a robot here. Gary, this is a little bit like the conversation we were having before starting here. But now I can actually use software to virtually explore how this thing would behave, in the environment. So I'm just toggling the speed of the function, but this is a simple example. So 3 key things: visualize, instruct, and interact, and then control. If I have time at the end, I will do a kind of fun another one where I'll drop a factory in the room here that we can explore. And I'm so happy that the technology here is working today. It can get pretty nerve-wracking up here when you plug something in and it actually doesn't show up. So thank you to the team back there that set all this up. Okay, so augmented reality. I want to dive in a little deeper here. So this company we acquired, Vuforia, we actually acquired it from Qualcomm. So it was a pretty well-established technology, particularly in the computer vision space. So is anybody here, are you familiar with an app called Vivino by chance? It's a wine app. You flash it at a wine label and it tells you, okay, that's powered by our Vuforia technology. So that's using computer vision to look at that wine bottle, collect information from other systems, and then present that information to the user. If you have kids and they use Nexo Nights, there's a whole augmented experience they can get on that helps them build up their Lego set, and that's powered by our Vuforia technology. So there's something like today 75,000 applications in the Android and Apple Store that use this technology. But we took it and we applied it to the industrial setting. And we actually integrated it with our ThingWorx platform so that you could very quickly create augmented experiences. So if you have SolidWorks or CATIA or Creo or UG CAD models, you can drag those CAD models into a little template without being a coder. You can connect them to data streams that you care about, either from machines or systems, and you can publish out augmented reality experiences literally in as little as the fastest one I've seen. You can go to our website and look at it. It's called AR in 1 minute. Uses a coffee maker to create an AR application in less than 1 minute. So very, very interesting capabilities that allow us to finally take AR to scale at the enterprise. But today we have about 10,000 companies that participate in our it's not a trial program, it's an online program where developers can go and download the software and experiment with applications they want to build, and then roll those applications into production, and I'll show you an example of that in a second. But we survey this customer base every quarter, and we ask them, what are you using AR for? And the first time we did this, it was a little bit surprising because it turns out they're using it for everything, kind of everywhere across their organization. The two big standouts, which actually you can almost group together in manufacturing operations and service, are around enabling and empowering what we call the frontline worker. So somebody whose job is to perform some task in the factory field, and you want to guide them through that task because maybe it's not the person who's done it 1,000 times before, it's a brand new millennial that has never done it before, right? And what's the most effective way to educate them on executing that procedure? But also things like training, and I'll show you an example of a training video. Like, can you apply this concept that cognitively humans can absorb more information digitally, and if you agree with that, I mean, if that seems to be intuitive, then why wouldn't you use that technology to train workers on how to perform tasks so that when they hit the factory floor, the job site, that they're more prepared to do that. Lots of use cases in sales and marketing. That hydraulic power system I showed was a case of how you might present information using augmented reality to your customers about the characteristics of the product, etc. And again, I can give you a couple more examples of that. So this is sort of the idea of augmented reality. If I look at a couple of examples, visualize. You know, here we're actually taking, this is a Cirrus jet, by the way, from the company Cirrus in Duluth, Minnesota, where we're looking at airflow, you know, over, this is simulated data because it was at our show a couple weeks ago, but looking at airflow, you know, over that jet, sort of live, augmented upon that experience. So that's, you know, example of visualize. I think I have my slide out of context here, but that's okay. And again, the idea here is that as we move to a digital world, humans need new tools. You know, you can't say I want to move to a state of Industry 4.0 where everything is digitized, but I still want to have my workers engage with paper documents, right? That those two don't come together that way. So you have to come out that backside with new tools for the workforce to be able to be relevant participants in the new digital economy. And this is the idea, is that there's so much data flying at people. How do you filter that? A great example, which one I'm sure you'll relate to well here in the Detroit area, would be maps in cars. You know, if we go back far enough, I started my career in sales, and I remember I used to carry the big paper maps in my car, and we're trying to figure out how to get to a customer site and looking at the map and trying to understand where all that was. You know, it was very complex. Then you got to a point where you have a map in your car, and you're trying to look at the map, and you're trying to then look up and apply it to the world around you. That was a huge step forward. But the new world is you augment into the screen of the car the guided instructions. And that's what's called cognitive distance. You know, the first example of I have a paper map, and I'm trying to study the paper map and apply it to the world, the physical world around me, is an example of enormous cognitive distance. This example right here is an example of minuscule cognitive distance, because it takes the human very little to look at the road and see embedded in the screen, you know, where they turn next, right? And that's where this power of AR will start to take hold. So to give you a real live example of this, this is BAE Systems. Most of us probably know them for the work they do in the aerospace and defense industry, but in this case, they also make batteries for electro-mobility buses. And I'm going to share a demo here, if this should work. Yeah. Okay, so this is a real use case. They are training workers who are going to assemble battery cells what that assembly procedure is. So they're starting out with the CAD data that they use to design that in their CAD system. And now here on the shop floor, it's a step-by-step guided procedure for those workers on exactly how you build up this demo. There's a much longer version of this available on the website, but I grabbed just a 30-second snapshot to give you an idea. So the benefit of this at BAE was that they said it made their workers, I don't know if it was some enormous number, 200% more efficient. But they did it by using this idea that Gartner talks about of a digital technology platform in a way that cost them 1/10 of what it would have cost to deliver those capabilities using other mechanisms. That's the idea. How do you harness the new technologies in a way that allows you to move very fast, but without the need to triple your IT organization at the same time? Okay, I want to give a couple more examples. This is another great example. So this would be a logistics in a warehouse. This is in some of the research that was done. I have sound here, but anyway, that's okay. I'll talk. So here you see two things, what we call assisted reality. So I'm the forklift driver, and I'm getting some instructions just painted into my, that's kind of like the map example, the middle map example in the car. I'm seeing the data, but I still got to apply it. But now you're seeing the actual augmented in-context experience where I'm driving the forklift and it's telling me exactly where to go and which bin to go from or go to, and then it's telling me, okay, now that you're there, pick up these two things and move on. So very interesting technologies. So I talked about IoT and analytics. I talked about augmented reality. Now I want to talk about the third sort of disruptive force around additive manufacturing. To do that, I would normally play a demo video here, but this one's kind of long. So what I wanted to use as an example, in Aachen, Germany, PTC works with this company called E.GO Mobile. And in fact, today the number one produced electric vehicle in Germany is a product called the street scooter, and that was also produced by this same organization here, and then they sold the company to DHL, and they use it today for their postal delivery vehicles in Germany and beyond. The founder, professor, his name is Professor Shu, then went out and started, he took that same concept of an electric vehicle, but instead of targeting at something like mail delivery, he's targeting it at urban, low-cost urban vehicle here. So it's supposed to cost like 12,000 euros or something, and provide a very lightweight transportation. So anyway, that's the background to this. But what we did with them, there's the chassis, and they wanted to look at how would they use additive manufacturing to take weight out of the wishbone assembly arm in the product. And so the first thing we did is we didn't just go straight to additive. We said, well, let's go out and drive the car around the track. Let's put some sensors on the drive assembly so that we can understand what the actual forces are that we're experiencing when we take that vehicle out. And then we took that data and we fed it into, in this case, our Creo additive manufacturing technologies to look at what is the best design. Since we did this, we've released some new capabilities in Creo around topology optimization, which are mind-blowingly interesting, where you can take that data, feed it in, and optimize the design, but then also optimize the topology of the design, but all keeping it in one CAD tool. Anyway, the point that I wanted to make here is by using real IoT data in combination with new opportunities for producing this part, they were able to take what was a part that was 1.9 kilograms and reduce it to 1.1 kilograms. So very interesting, not by any means scratching the full potential of what additive manufacturing is bringing, but an example that's very meaningful, certainly to the auto and aero industry in this case. Okay, so IoT and analytics, augmented reality, additive manufacturing. That brings us to the fourth one of what I said are my favorite. Again, not exclusive. There are other technologies like blockchain and even robotics is going to completely transform the manufacturing environment as we know it. I kind of, in our context, I bring robotics into IoT because I think they're one of the things that are contributing to the connectivity and automation opportunity. But in that field alone, there's a tremendous amount of innovation going on. But the fourth example was this idea of a digital technology platform. And here the concept is, if you have a technology platform that allows you to integrate all of these different technologies together, these disruptive technologies, and then move very quickly in applying the collection of those technologies to your transformation initiatives, how much faster could you move than if you tried to build them all together yourselves? So in the PTC world, when we talk about a digital technology platform, this is the picture that we refer to. We're talking about technology that allows you to source data from wherever it is, and I mean wherever it is. You can pull it from a PLC that might be connected to a device operating in the factory. You could pull it from an IoT gateway that's been added to a brownfield environment with new sensors to pull other data out of the factory. You could pull it from the cloud or multiple clouds. So you might have some data that lives in AWS and you might have some data that lives in Azure, and what you want to actually do is source some of that data, bring it in and develop an application that spans all of those systems as well as some edge technology. In data though, it's also pulling data from SAP and your MES systems and all of that so that you can combine that together. So the first thing is to source that data. Then there's this idea of you want to be able to contextualize it. You want to be able to abstract your sort of mental model of what your data structure looks like away from all the complexity that exists site by site and technology by technology that underlies it. So here you can standardize a data model, or I guess the term is a data ontology, that allows you to program applications against that can look very standard across the enterprise, even though the underlying infrastructure is drastically different from one site to the next site. So the second piece is really about contextualizing it. Now that you have the data in sort of a normal data structure, and you're pulling all this data together, you can begin to apply analytics. In the industry, I guess we call that, the first is descriptive analytics, which are basic sort of rules, SPC kind of rules, et cetera. Tell me, based upon thresholds and limits and things like that, what's happening with the data I have, knowing where certain thresholds are that I care about. The second would be applying predictive analytics. Let me look at the sort of data flowing and detect when there are anomalies, and then understand, are those anomalies representative of patterns that have led to certain negative outcomes or potentially positive outcomes in the past, to make predictions about what's going to happen. And then the third is really around using that data to say, well, if we could always look at our data in this way, we know it would produce a good outcome, start to apply prescriptive technologies. But there's another type of analytics too, which is using things like ANSYS. So can I take data streams and feed them back into the design tools my engineers use to actually see what's happening in the design environment based upon the data that I'm collecting back from the field. So I'll show you an example of that in a second. Okay, so now that we've applied all these rich analytics to the model, we want to know when something happens, how do we react to that? So it might be we just had that example of the furnace failing or throwing an alarm on the assembly line, automatically open a ticket in our maintenance system to dispatch the maintenance crew to the next time that they should fix it, right? There's no reason that you can't systematically do that. Or it might be, you know, send a note to the shift manager, a text to the shift manager telling him or her to go adjust some setting, right, so that you don't end up in a situation. So that's really what this idea of orchestrate is. And then engage comes back to the idea that you want to engage either systems or people. If you're talking about people, well, there's many ways you can engage them. You can engage them through their mobile devices. You could engage them through sort of 2D web applications that might live on their computer, on their desk. Or, as I've shown you some examples, you could engage them by delivering that information to them using augmented reality to do something that is very, very meaningful in the context of whatever the needed response is. So this is our ThingWorx industrial innovation platform, but it integrates the technology that allows you to connect to devices and clouds and business systems. It integrates our analytics technologies, but also provides a framework to plug in, to snap in other analytics tools that you might want to use or probably are already using. And it integrates the augmented reality technologies that give you the opportunity to serve up the information, particularly on the human side, in a completely different way that enables what I referred to earlier, sort of superhuman capabilities. So let's look at an example of that. This is a flow-serve pump. You find these things typically in oil and gas kind of environments. They're just giving you, you know, there's lots in this we call optimization sensors added through a National Instruments gateway. We're collecting lots of data. We're running that this entire system not in the cloud but at the edge on an HP Edgeline computer. We're creating cavitations to show a demonstration environment. Cavitation is a bad thing with the pump. What you can see is when we create the cavitation, it immediately triggers a whole bunch of negative anomalies and alerts people to the fact that you know, our efficiency is way off, but more importantly, infection for 3 days, we're going to end up with a pump that's no longer functioning, right? So from that, I don't know where it shows up there somewhere, we also then opened a ticket in the enterprise asset management system to make sure that somebody got to resolving that. And then the final thing we're doing is we're just displaying, this is a simple example, but we're displaying the performance characteristics of that pump to somebody who might be wanting augmented reality or you know, might be a supervisor walking the plant who wants to look at it and understand how is this thing performing right now, right? And you can see all the characteristics. So if I use that as an example, and in this example, I mentioned this already, we also did an effort where we took the data from the sensors, we fed it back into the ANSYS model, and then we could see inside the ANSYS model that in fact cavitation was happening. So we had a predictive model that said your pump's cavitating because we see these data streams and patterns, and we know based upon having seen that before that that's cavitation, and oh, by the way, when that happens, you have, based upon past failure data, we can see that you have 3 days to failure. But we also took the sort of opposite angle and we fed that data back into the ANSYS model, and then we looked right inside the ANSYS model and we said, well, based upon what's happening with the sensors on that pump, we actually can tell you right here in the model that cavitation is happening in the pump. So 2 different ways to look at that area. But in that simple example of this pump, this digital technology platform is in action. It's pulling data from all kinds of sensors, both embedded sensors in the pump as well as secondary sensors. In this case, we didn't go out to the cloud, but we could have. It's pulling some CAD and PLM data and other data from the CAD and PLM systems and using it in multiple ways, but one when we finally delivered that AR experience. It's using multiple techniques for analyzing the data, a predictive model. Well, first some descriptive dashboards that are telling us that there's some anomalous behavior happening that's outside our desired thresholds, then a predictive model that tells us when it's actually going to fail, and then the ANSYS technology integrated in to confirm that what we're actually seeing is a problem, and that's, you know, useful. It's 1,000 miles away. And then we are orchestrating a response, so we went out to a business system and opened a ticket. And then we, in this case, you saw multiple dashboards. There was a 2D dashboard that somebody might be looking at just monitoring that pump. Deployed an augmented reality experience to the factory manager that's walking the factory. And did that all relatively simply inside this industrial innovation platform. Okay. So technologies are converging. I think we all know that technologies are developing at an exponential rate. At PTC, we have a phrase that we say, you know, we've gone from a place to a pace, meaning, you know, we used to, if back up, I've been at PTC 20 years, if I back up 15 years ago, at one point, Windows was, you know, we started our CAD system and on a Unix operating system, and at one point Windows became a very important technology force that we had to assess, like, how does that impact us? And to be frank, we were kind of slow in doing that assessment. But we had the luxury back in that day of sort of looking at one of these technologies semi-independently and studying it for a while and then figuring out how to act. I'm not sure that's the world we're in today. You know, there's so many technologies, they're moving so quickly, you really have to figure out how do they apply and how do we leverage them most meaningfully. So, but it's not just about technology for technology's sake. The idea here is that you use these technologies to drive business outcomes. And so we have developed, really through conversations with thousands of customers and prospects, the idea of these digital transformation journeys. And so we have one for engineering, a digital engineering journey, a digital manufacturing journey, and a digital service journey. This is the manufacturing example. So in this example, what we talk about is there's really, you know, you should think about this. It's not like tomorrow you flip the switch and you're digital. You know, your environment is all of a sudden digital. It is a journey, and it's going to take some time to get there, and it's going to take technology, and it's going to take process change and probably change in management KPIs and a whole bunch of things before you get to this completely transformed state, and it will take some time. But you can think about it logically in this kind of construct, that there's some basic things, we call that understand. There's like a basic layer of the foundation of the house that you have to build. There's advanced technologies that you can apply to that layer, and then there's ways that you can leverage those technologies to drive entirely new capabilities or to tie together the enterprise. And so from an understand perspective, it's about unified connectivity, real-time issue identification, and then operational intelligence. And so unified connectivity is the idea that you're no longer constrained to IT systems that know IT data and OT systems that know machine and sensor data. You can bring all that together into this contextualized environment and have a unified data set. Real-time issue identification is the first phase of basic analytics, the descriptive analytics. Let me then set some rules and alerts and notifications against that data so that when something that I intuitively know is wrong, like the temperature of equipment should never exceed this particular number, please give me an alert immediately if that ever happens, respond to it. And operational intelligence is about help me then serve that information up so that the people who need it have instant or near instant access to it so that they can react as problems or opportunities are developing. So what do I mean by that? Some examples would be, if I'm the plant manager, the production manager, I probably want to know what are the KPIs of my line. How is my line running? What's my OEE? Maybe it's about how are certain operators or workers performing? Is there somebody who might need more training or whatever? Give me this data contextualized so that I can see it in the world that I care about. If I'm the maintenance team in the factory, I don't necessarily care about all those KPIs, but I do want to know if there's any asset that has moved from a healthy state to an unhealthy state. And if it's that example of the furnace on the production line, I want to know immediately so that I can schedule and get that issue resolved before it results in unplanned downtime. If I'm the controls engineer or the plant engineer, and my job is to make sure that everything in the factory is connected and wired together, I might just want to know, please tell me if any of the devices, the endpoints in my factory, stop talking or are offline, because for me that's a problem. I'm then missing data. If I'm an operator, the real-time data might be, show me the work instructions that, or the work order that I'm supposed to be executing alongside the proper machine settings and maybe KPIs that are specific to that machine that tell me or help me inform how I better do my job, right? So the idea of operational intelligence is providing real-time access to actionable insights that can impact the work that somebody's doing in the moment to, you know, either drive opportunities or prevent problems from occurring. Then if you move out a layer, if that's sort of the foundation that's built as we're collecting data, we've put that data together in a logical way and we're informing people when things are happening to the data that they would care about, then we can start looking at applying more of these advanced technologies. Now I can say, well, let me look at that OT and IT data set in combination and identify, are there some predictive algorithms that are going to tell me about how to improve or avoid a problem from happening in a certain period of time. I can start to say, well, let me take that data and instead of delivering it to an operator through a 2D web screen, let me create an augmented reality experience so that I can deliver it that way. The idea of a digital thread is let's make sure that the engineering data that's created upstream has a direct pipe to manufacturing. I mean, it's hard to imagine an environment in the future where we've digitized manufacturing, but we didn't connect it back upstream to engineering, right? Or at least it'll be a little bit chaotic if that's the approach. And then this idea of agile innovation is let me stop thinking about projects in my factory that I run that might take a year to upgrade a system and start thinking about how software companies react in digital space and start thinking about short projects that if I could just ask, like, what is the next set of data that I would like to have and who would it benefit, and if they had that data, what problems might it solve, then let me take a 6-week cycle and go build an application out of this environment that delivers just those capabilities. So those are applying advanced technologies and advanced methodologies to this sort of data foundation. And then in the outperform area, it's really about how do we leverage that. So you can move from, you know, again, there's descriptive, prescriptive, and, descriptive, predictive, and prescriptive analytics. You know, now you can start to use your data to say, well, what should it look like in a perfect world? There are very few people doing this today, but that's the path that everybody's interested in heading down. Synchronized operations. How do I, if I'm running a factory, how do I connect the work in process inventory, the trucks that are arriving perhaps at the dock with my workers and the skill sets that they need and maybe the tools that are required to execute a particular operation. Performance benchmarking is this idea that you can actually standardize KPIs even though you don't need to standardize all your factory infrastructure. So the example of the food and beverage company that I showed, they have potato chip lines that go across many, many factories, and every factory is different. But by abstracting, by creating that contextual model that exists on top of that for every one of those lines, and then look at the sort of traditional analysis of why is it that a top performing line is, you know, so much more efficient than these other lines over here, and what could we do, either by investing in new systems and infrastructure to lift those capabilities, or maybe by making process changes. And then supply chain visibility is really about tying together all components in the supply chain, from the demand perspective to the suppliers, the logistics, and both inbound and outbound logistics. So this is what we hear customers wanting, you know, when you talk about Industry 4.0 or smart factories or whatever the name du jour is. Really, these are the kinds of conversations that we tend to have, is this is where people want to get to. They want to connect things. They want to start to use these technologies to enable them to do things they couldn't do before, and then they want to be able to leverage that across the enterprise or outside the organization to create a more consistent and comprehensive sort of digital thread. Okay, just a couple of slides to kind of tell you how we support that, and then I'll open it up for questions. So as I mentioned, we have this thing we call the ThingWorx Industrial Innovation Platform. That includes at its core contents, industrial connectivity, foundation, analytics, and augmented reality. We then have these concepts of accelerators and apps. So we've built a number of applications. ThingWorx Navigate is really meant for the engineering community to allow you to tie together different data sources, primarily from PLM and ERP and other systems. ThingWorx Controls Advisor is an application that helps plant managers track connectivity, plant engineers track connectivity in the factory. ThingWorx Production Advisor is an application that allows plant managers and production managers to stand up KPIs about either machines or the lines that they care about. ThingWorx Asset Advisor is a way to look at all the assets that exist in a factory and be able to connect them very quickly and start monitoring the health status, and then be able to drill in and look at sort of root cause analysis when problems develop. We'll be launching later this year something called ThingWorx Operator Advisor. I'm not sure that'll be the name, but the idea is that here we're helping integrate all of the data sources for the operator, and then looking at, again, is it best to deliver the output of those integrated data sources in a 2D web environment, or using other technologies like augmented reality work instructions. ThingWorx also has a big developer zone. There's over 400,000 developers that participate in the ThingWorx aggregate developer zone. And then there's a marketplace. So we have partners who build extensions or capabilities. It might be an integration to a system or something like that, and they can publish that to the marketplace. I'll make these slides available, so I won't go through all of this.